Let's take a look at another algebraic technique we can use to simplify a rational function, this one involving a radical in either the numerator or the denominator. So let's go back to a function we looked at earlier in this particular topic, and let's take a look at our function g of x, which we said was equal to the square root of x minus 1 in the numerator and x minus 2 in the denominator. And you'll recall that we assigned the domain of this particular function, and we looked at a couple of things. We said, first of all, we can't have x be equal to 2 because that gives us a 0 in the denominator. And then we also said we knew that x minus 1 had to be non-negative, so we said the domain of this function was 1 to 2 with 1 included, 2 being excluded because it makes the denominator 0, so we unioned it with 2 to infinity, and that was the domain of that particular function. Well, we can use this idea of a conjugate to simplify and rewrite this function. So let's define what a conjugate is. The conjugate is something that is formed. It's a binomial expression, and it's formed by taking a binomial that you already have and simply changing the sign of a binomial. So remember, a binomial is two terms that are just being either added or subtracted from each other. And we actually have a binomial in the numerator as well as the denominator. The binomial here, the square root of x minus 1 is my first term, 1 is my second term, and they're being subtracted. So I'm going to look at this numerator here, and I'm going to form the conjugate by changing the sign of this minus sign. Now, the minus sign that's underneath the radical here is not going to change. It's the minus sign that's separating my two terms. So let's take a look at how this is going to break down. I'm going to take the square root of x minus 1 minus 1 there, all over x minus 2. Well, I want to multiply the numerator by its conjugate, so I'm going to multiply it by the square root of x minus 1 plus 1. And the only way I can do that is if I also do that to the denominator. So I'm going to multiply it by the square root of x minus 1 plus 1. And what I'm doing is a very complicated way of multiplying this rational function by 1. Because if I have something over itself, as long as it doesn't come out to be 0 over 0, I'm just simply multiplying it by something that's 1. The reason why the conjugate works is because it uses, so let's make a little note here, the conjugate uses this idea of the difference of squares. And what it does is it produces this difference of squares. I'm going to throw a formula on here that you'll probably recall from earlier algebra, and that is this idea that if I have a plus b times a minus b, that simply equals a squared minus b squared. And as long as a and b can easily be defined, and you can kind of see that they are the conjugates of each other because the sign changes, then I produce the difference of squares, and that's what happens in the numerator here. I have a, which is the square root of x minus 1, times a, and then the only thing that changes is the sign between minus 1 here and plus 1. So when I go to simplify this, I get the difference of squares. So I can take a look at the square root of x minus 1, and I can square it as my a squared here. And the square root of x minus 1 squared is simply x minus 1. And then I've got 1 squared, that's going to be my b squared here in this formula. So 1 squared is going to be minus 1. Now the denominator is going to be gross. I don't want to try to do any kind of FOIL or distribution here. I'm just going to let it kind of sit the way that it is right now. And that is taking x minus 2 times the square root of x minus 1 plus 1. And some of you might be able to see what's going to happen here. I'm going to simplify the numerator by taking x minus 1 minus 1 and rewriting that as x minus 2. And the reason why I didn't want to do anything to this denominator is because this gave me x minus 2. And we'll address that here in a moment. square root of x, that should be minus 1 plus 1. So make sure you keep your signs correct here, as that's a minus 1, but a plus 1 outside of it. And now I'm back to this idea where I've got factors that can be divided out. So I can actually rewrite this and say it's 1 over the square root of x minus 1 plus 1. Now then, just like on the previous video, the domain of this function was already laid out for us. 2 got excluded from the domain because it made the denominator 0. It no longer does in our rewrite. In fact, I could plug 2 into this function and actually get a value. But remember, because I already excluded it from my domain. So let's make a note here. X equals 2 no longer makes the denominator 0. But it still is excluded from my domain because I had to exclude it at the beginning. All I'm doing here is rewriting g of x. I still have this domain that applies. So the domain of g of x is still 1 to 2 with 1 included, union 2 to infinity. Now then, one of the things that comes up in calculus, we will talk about x equals 2 because something special is happening there. But it is not a part of the domain of the function, even though I was able to rewrite it in a way where 2 was no longer giving me a 0 in the denominator. So it still has to be excluded from the domain, but in calculus we'll actually talk about something very special that happens at x equals 2.